All right, on January 22nd. All right, let's do this. So we'll have to keep going. We have to keep going with this one. It was just never correct. Never correct. All right, let's finish this one first. Maximum length of a concatenated string with unique characters. I'm doing LeetCode. You look great. You are given an array of strings. String S is formed by the concatenation of a subsequence of array that has unique characters. Return the maximum possible length of S. Subsequence is, we know what a subsequence is. So the first one, which just means we pick something, right, from the array to put them together such that the result is going to be a string with unique letters, which essentially means the longest you can get is 26, right? The longest you can get is 26, and array I contains only lowercase English letters, but array I didn't say, array I can have repeated, I can have repeats, right? It didn't say it does not have repeats. Okay, so subsequence, right? And given that the length of the array is so small, we can basically think it's kind of like a knapsack problem, right? So you have a bunch of things, because it's subsequent, so it doesn't really matter. And then order doesn't matter. So it's just a bag of strings, and they say we want to pick each one only once. So it's like a 0-1 knapsack. And you'll pick each one and you put them together into a bag. And the requirement is there's no repeats in the stuff in the letter. Yeah, okay. So, and we want to find out what's the maximum length it can get. Can each thing be having repeats? I guess it can. I never say it cannot, so maybe it can. We can test it out. Like, do this and do this. That is allowed. So the answer should be 2. Yep. So it is allowed, so we have to check as well. Now, the thing is, we need to write a helper function to check if the substring contains duplicates, right? What would be an easier way to check for duplicate? Well, an easier way to check for duplicate is, 26, right? It can be we can do bit mask, right? We can do bit mask. So 26 positions, and each array value is going to be turned into a integer, which it's a bit mask, right? And when we putting them together, we are ORing, right? We OR them together. But before we OR them together, we need to AND them, and their AND must be equal to 0. Otherwise, we cannot. Otherwise, they will be duplicates. Okay. So we say DPI equals to DPI will equal to the maximum possible length of S. We start from array I towards the end, right? And what we want to find is DP0. And for each DPI, what we can say is we will include DPI, array I, or we don't include DPI, right? I think that's perfectly fine. And if we don't include it, it will be the remaining. If we include it, we'll take this and have the remaining. Oh, and then we'll also need to have the current state. We do need a current state. So it's a DPI and index and state. So two things. It's two things. Okie dokie, okie dokie. So we have 2 rounds of this thing going, but I think the strategy is pretty clear. Ooh, did you change anything? No, I did not change anything for it. But by the way, JWST image. Maybe I choose a different one for this. I chose this. Maybe I should choose for a, let's do, I mean, I've seen this one before. This one. Ugh, this has a, I don't like it. I'm choosing a background. That looks pretty cool. Yep, there you go. You're the one. Save image as JWST. Okay, now we need to know how big this file is, because it can't be too big. 39 KB, that's fine. Then we're gonna do this. We go to profiles, window, enable, go get this JWST. There we go, that's what I'm looking for. Don't stretch, scale to fit. And I'm gonna make it darker. Yeah. Good. Right, that is what I want. And then when I do this, booyah, look, I have a beautiful background. That's what I learned yesterday. That's what I did yesterday. It was awesome. It's really awesome if you do this. Haha, that's really awesome. But we're not doing it. We're not doing this, so it's okay. Okay, let's go. Yeah, sometimes I do feel a bit distracting, but that's okay. I think it's fine. I think it's fun. All right, so a few things. So we need func tools. We need IO cache, and then we need to do. First things first, we need to check, right? Create new array that removes any string that contains duplicates. So we call it new array. Go to this. And for an array, right, we need to say mask starts with 0. And then for lettering A, right, if 1 left shift remembers ord, right, ord letter minus lowercase, remember 97, right? If this and mask is not equal to 0, then we'll break. Okay. Otherwise, mask or equal to 1 left shift ord letter. Be easier to do this. We can just say I equal to ord letter minus 97. Okay. And then all of this become I, right? We don't need we don't need this. We don't need this, right? And then here is the same thing. We don't need any of this, just I. So mask or equal to this, blah 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 at the end. Why is this not working? Hold on, something is not right. Let me go here. Let me pull again. Yeah, it's up to date. I have no idea why it's not working here. It should be working, but it just goes to the front. I don't understand. Right? Something is not right. Hold a second. This is right. Did I made a mistake somewhere? This is also right. This is right. I don't understand. Now everything is right. I have no clue. Anyway, oh, I know. Maybe this one. Okay, this is wrong. It should be this. That doesn't work. Anyway, we'll do else, right? So if we break, then we don't do else. If we don't break, that means we finish. Wait, I forgot. Is else happen? Is it when we break or when we not break? I think it's when we don't break. Oh my goodness. Python for else. I forgot. When the loop is finished. Yes, that's correct. So else, we basically say new array dot append mask. Okay, so now we create a new array. Next is LU cache, max size, none, and we'll define a def dp index and index on what? Index and a mask. State, we'll call it state. Okay, turn the state. Okay, so what is the end state? Index, we're trying to return the longest length, right? Which means if index is at the end, so we go to the last one, right? If index is at the end, or I will just index equal to this. If index is equal to len new array, I say we return 0 because you're going to the end, so there's no more for you, right? Otherwise, then you always have something, and you can always say rest will equal to dp index plus 1 state. So this is not taking a new array index, or we take it, right? Or we take new array index, which what we do is if state and new array index is equal to 0, right? Which means they don't have any duplicates. So when that happens, then we can say res equal to maximum res and len. Ooh, I don't know the length. Dear me. It has to be this. Oh. Mask and len a. Ugh. Yep. Unfortunately. So this is 5. And this has to be index 0. Right, that's the mask. and this is a new array index 1 plus dp index plus 1 state or new array index and 0, and do this, and at the end we'll return res, right? And we'll return dp, we start from 0 and initial state is 0. Okay, 24k. Let's take a look. Yeah, I feel like it has to go a little bit darker. Something like that. Okay. Yeah. This is good. Does this have a hint, right? A hint. There's a hint of we're in the space. Okay. Is this correct? Looks good. Looks good to me. We're gonna go. And yes, that was good. That was good. Oh, it's a difference. Big difference between this time and the last time. I wonder why. Do we have any difference in the number of cases? 89, 89. DFS. Oh, I was using union. Why did I call it DFS? New as set. Oh, it's the same idea, right? It's the same idea. That's the same idea, but this is much better, right? So, okay, let's do some explanation. We use bit mask to represent each string in an array, and the final concatenated final concatenated string the benefit of using bit mask is that we can determine whether there is duplicates in O1 time. Then the problem is no different from a 0-1 knapsack, which can be solved using DP. Now the runtime will be interesting. So the runtime shall be O something, right? What's this O something? Well, we have N because we are going this time, and state is 2 to the, call it 2 to the, it was actually no, 2 to the 26, right? Because we only have 2 to the 26 different states. So I guess, yeah, that'll be it. All right, this is good. Now we're back to this. Oh, we had a good run in the morning. I thought we got this. All right, 1, 1, 2, 2, 9, and 10. Okay, so in this one we go binary search. So So we start with low is 0, high is 1, 2, 3, 4, 5, 6. 6. I do 7, right? So the first one, mid is 3. 3.5, so it's 3. So it's 3 possible. So we count. If it's 3, it should be 3, 2, 1. So 3 is possible. So now we have low is 4, high is 7, and mid is 11. So mid is 5. Ooh, we should see 5 is possible. So 5, we need 5, 4, 3. Right? This is a 3. Actually, no, we go from low to high. I was not going from high to low, right? No, I went from high to low. High to low and have the requirement. And it's requirement minus, now usage minus requirement. So these cannot be used. So this is a deficit, okay? So now deficit is deficit minus 1. It requires 3, only have 2, right? But anyone 2, 1. Oh, we have an extra. God. Man. Oh, man. So what you mean is we don't break. We don't break. We don't break. We go through the whole thing. And if requirement is 0, oh my goodness. So we don't break it. We say equal to if requirement is larger than 0, then requirement minus equal 1. But if requirement becomes 0, we don't do it. And this is 0, so we have, oh, then this one will pass. Dude. This problem might finally be solved. 3 days. 3 days of struggle with a little bit hint that tells me you should think about binary search.
Just looked at it.
Well, I looked at it this morning because all my other methods don't work. So this morning I'm like, let me just take a look at the hint. But I didn't even look at the hint. What I look at is what's the method is involved. And I saw greedy and a binary search, and immediately, I think I know, but still wasn't able to solve it this morning. But right now, I saw where I was wrong in the morning.
You did LeetCode online?
Yeah, because I didn't do LeetCode last night. I worked a little bit too late, and I feel like it's too sleepy. So I just, I'll do LeetCode this morning, because I know this morning I have to wake up early to catch the market. Which is very necessary, because I know charge point just jumped immediately after open market.
When did you wake up?
6:20, I think. Because I did some trade and I went back to sleep. Night night. All right, I'm back. All right, looks promising. Let's do this. Come on. Come on. Oh, finally. Oh my God, finally. Finally. Is it a good solution? No. But it works. It works. Okay. Let's see if we can improve it. Because apparently it's very slow, right? It's very slow. So what can we do to make this better? Now, what we can do is if we compute the sum, because I feel like maybe we can do prefix sum, right? Now in this case, if we start from here, it's going to be 10, 19. I don't know. I go 10, 19. So what I want is I know the total needed, right? I know the total need. This one I can compute. This I can compute. All I want is to find from this add everything together. It needs to be larger or equal to this. Except anything bigger on the end cannot count. We can only count the maximum. We can only count the maximum. How can we ensure that? So if we sort it, okay, if we sort it, we can go from right to left and eliminate the ones that, I don't know. I don't know. Or, yeah, we should, like, because we know these will always work for no matter what, right? So these never counts, right? These never counts. So we sort it, and then we check, because at the biggest this can be is 1, 2, 3, 4, 5, 6 is 6. And it's larger than 6, so we just ignore, right? So we always ignore. Basically, we say there's always going to be plus 2 for this thing. So this problem is converted to do 1, 1, 2, 2, right? We just basically do 1, 1, 2, 2. And then we just want to see if it's possible for this to match whatever that we want. And in this case, we'll do 4. 4 need to be 1, 2, 3, 4. That's 10. And we don't have 10, right? Yeah, we don't have 10. So the next we say, okay, next is we start from 3. Then we need to 6. 1, 2, 3. We need a 6. Do we have a 6 here? And the answer is yes, we have a 6 here. So, yeah, we're good. So, what do you think? This idea? What do I think this idea? So we go for the first one that is below the requirement. Because if you're above the requirement, you're always going to work, right? And the first one that's below the requirement, and everybody else will be below, everybody else will not be above, right? And then you can try it. I mean, talk is cheap. Let's get to see this. Like this one, 33171, right? 33171. So we go, it become 11337, right? So the largest is gonna be 1, 2, 3, 4, 5. So we eliminate this, So we don't consider this, and we always have a +1. Then we'll solve this. And to do this, we need 10. We don't have 10. Right? We just add to this. What's the sum? 1, 2, 8. Right? That's 8. So 10 is no good. But 3 is going to be 6 is good. So the answer is 4. The answer is 4. That is interesting. That is very interesting. Okay, so first things first, let me place this. 2,257 milliseconds. Call it solution 1. Now we're gonna do solution 2. This uses the same idea, but we might be able to simplify the procedure drastically. To begin with, after sorting usage limits, if the large values are bigger or equal to the max repeats needed possible, then we don't even have to, right? Then we don't even have to consider them anymore, because they will always be able to work towards they'll also be able to contribute, right? Always be able to contribute to additional. Always be able to contribute to what? Yeah, why did you say like this is +1, this is +2? Because this one we always can make one more for it, right? We always can make one more for it. So these two is like guaranteed. Like no matter, yeah, and they'll always be able to contribute to one additional group. In other words, if we have m usage limits that are that I don't need AC. Well, I don't even know what this is. Are bigger or equal to the max requirement, we will have at least m more this is really annoying. This is very, very annoying. It's a snippet, right? I need to disable snippet when I'm in the command mode. get rid of a snippet. Cat goose. Always work in progress. Config.source lua snip group in the option use show condition entry filter. This is the entry filter, right? Local context require this, not context tree sitter capture. Oh, it's from Cat Goose's NeoVim. This one. Alright, I'll try it. You know what? I'm gonna try it right now. You need this entry filter. Yeah, that's what I thought. It's not a CMP enabled key that controls what a CMP display at all. Now I'm just gonna try this. How do I try? Let's go. Naturally, I need to take a look at. Hold on. I need to take a look at the. Is it LSP setup? Yeah, I feel like it's still too bright. Maybe that's not the best picture. Maybe 15. Earlier it's 22, I remember. Okay. Or changes sometimes in the future. No, this is LSP. What we want is not LSP, right? No, what we want is not LSP. What we want is CMP. CMP setup. Something like that. CMP.setup. Snippet. Look, snippet enable. Lua snip. Lua snip. Expand. Completion. Mapping. Sources. Damn, what was the one here? Sources is cmp.setup. Sources equal to cmp.config. Huh. source. I think it's this thing, right? Name is lure snip. Then we should do an option, which means we should take this thing. But this is an insert, so we need to replace the whole thing. I think that's what it means. Okay, what I'm gonna do right now is a new command, which is Control WV. There we go, and we'll do search file. Go to my options, custom config. This is my custom config, and I have one for this, right? And now I set mapping the insert enable equal to function. So this is the enable, right? This is to make sure it won't be enabled in a comment. And next we're gonna do sources. Enable equal to this. Enable the function. I'm pretty sure I need to do this. And sources equal to. Probably need to, I don't know. Probably need to copy this whole thing. Not 100% sure, but I'm gonna try. So we're gonna paste the whole thing. Okay. And I mean, we can try if we don't use this and don't use this, but I don't feel that's right. Huh. Why the number of there you go. I don't know. Do you want to try? Just we comment on this, and then we just work on this. Oh. Okay, now we're gonna copy this. I think it's there we go. Local context is, let's see, it's the same as this, right? Context dot intriciter is in string and not context in syntax group. This is actually a stupid way of doing it, right? Line with trading space. All right, so basically this is a return not context.string. So entry filter, if it's not in the string, it's true, right? So it's true. Whenever it's true, we will show it. So true is if it's not in string or it's not in the other string. Okay, looks good. Let's okay, let's take a shot. Probably have to. Okay, so earlier, which one get triggered? I think here we get triggered. Oh yeah, was good. Right, but we need to see if it still shows snippet. How do we still show async? Yeah, it still shows, right? but here async I don't show anymore. Right, and then here async still show. Time, yeah, these are snippet, they still show. So I think this is right. But I'm not 100% sure. Because here is insert, right? This one is insert. So if I load this one first, or load this one first, I load this, it's okay, I just insert more things. But here I load this first, and then I load this, and these gets overwritten. You know what? I don't feel comfortable. Let me just re-enable these. Okay. And I think this is pretty stupid, so I'm gonna rewrite this one. Local context equal to... We're basically gonna yank this one. We'll paste this. Right. Okay, so we have a local value of context. And basically, with enabled is false. So we shall return context dot entry setter comment. Right? So if it's in the if it's inside a comment, we shall return false. We shall be false, so it should be not. Right? If not this, or this is in syntax group, not context dot in syntax group comment. So by that, I think I can, hold on, let me just select these if else and then we're gonna go comment it out. Okay, try it again. All right, so what we want to try is to see. Okay, that's still good. We have the autocomplete, but inside a comment we should not have. That's good, right? Not only that, we don't have a snippet as well. Good. I think this is good, and we can delete these. Say D4J, right? Okay, I might want to comment this. I'm gonna say disable autocomplete inside comments. We can actually do inside strings, but yeah, we probably should do inside strings. Well, we know how to do this, and then we'll do it if we need it. And this is disable snippet inside string. Right? Good. I think that's good. Do you think it's or and? Because this is entry filter. It is not in string and not. When it's not in string and not in string, then we will be true. Oh, because it's a filter. It's different from enabled. Enabled is the other way around, right? Enabled is true. Means the enable, we want to disable it. So both has to, yeah, enable is true if it's not in this or not in this. But entry field is true if you're not in, yeah, it should be not in string or not in string. What is end? No, enable is false. Yes, enable is false. If you're not, if in comment that as a true, so we return a false. So enable is false. But entry field is when we show this, right? If it's not in this and not in this, then you show it. And I guess comment counts as string. That's a good thing. Thing to try. Like we say a equal to a math dot. Right? We can say math dot. Yeah, I don't show it. Right, but outside math dot we show it. So I think that's good. Okay. I am happy. Yeah, I don't think I changed anything here. So what do we call this? Disable snippet when inside a comment, or inside a string. All comment. Good. All right. So that's good. That's one big problem solved. Yeah. What I was trying to do here. If we have users that are bigger or equal to the max requirements, we will have at least m number, right, of additional groups for free. Right. Thus, we don't even need to consider them. Yeah. Therefore, we don't even need to. Yeah, for free. I already said we don't have to consider them. We only need to consider the values, right, the limits that are smaller or equal to the max repeats, right? That's what we're going to consider. And we don't have to consider them one by one. Right, instead, we can simply add them together to see if the total number of repeats is larger or equal to the required repeats. If yes, we can form the required number of groups, otherwise not. Okay, so with that, again, this one we'll sort it first, right? And then we're gonna find the maximum, right? Maximum, and then we can say length n, okay, shall equal to len usage limits. We say while usage limits n minus 1, okay, if it's larger or equal to n minus equal to 1. So this one will end, right, this will end whenever on the current n, while n is larger or equal to 0, and actually it should be larger than 0, cannot delete, right, and this element is larger, that means this position is good, right, so we can just ignore it. And at the end, we'll find an n which we cannot ignore, right, so that is the position, right, that is the position. And we also know the free is going to be len usage limits minus, this is free. We get these additional groups for free. You're in comments and I still do this. Oh. Holy crap. Yep. No good. No good, man. We have to go custom. So down, down, down. So not context dot is syntax group is tree setter. Let's go tree setter first. I think we have to do comment. Okay, and not context dot comment. In fact, I'm gonna copy this thing. I'm gonna do it here as well, because this, you don't want autocomplete to be in the string as well. So we should say or not context dot in tree setter string, right? It's under lowercase string or not context dot in syntax string, right? Yeah. Okay, let's take a look. Let's save it. Okay, and so get back up, down, down, down. Okay. There we go. I think this one's right. We get these in for free. Yeah, I don't have anything. I don't have anything coming with me. Right. Earlier we have stuff async. Yeah. Okay. So that's the one. That's the one. Nope. That's. Ooh. That's. Oh, can I? I already pushed. Jesus, can I push again? No. God. Oh my god. Oh my god. That's very bad. I committed into one, and then the two history is different. Dude, you're so dumb. Now what? At the behind is remote counterpart, so I have to get pull. Okay, we have a conflict. Hold on, I don't think that's right. Maybe we should go Vim on this one. Custom, wait, Lua, custom config. There you go, that's the one. Okay, so head is this. We will do return king this. Okay, well, head. Fix merge conflict. Yeah, conflict. Okay, and then we push. There we go. Oh my god, it's just, yeah, I know this rule. I forgot. All right, where are we? So we get free. So these are for free, right? And after that, we will do binary search. So low is 0. Okay, we can say low, high. 0 and n plus 1. This n is not the original n, this n is the fixed n. We also need a sum, right? We need a sum. And then we say total repeats is equal to sum usage limits all the way to n. Again, it's not everything, it's all the way to n, right? So we have the total repeats. Now we can say while low smaller than high, mid is equal to while low plus high divided by 2. That's fine. And we can compute the required is 1 plus mid times mid divided by 2. Okay. And then what? Then we say if required is, if total this is larger or equal to required, then we say low plus equal 1. Right, it can be higher. Otherwise, high equal to mid. And we'll return low minus 1 plus 3. Okay, let's take a look. 15K. We have bunch of, wow, this is ON plus log n. Is this right? Yeah, it might be correct. Ugh. Oh, it hurts. This one hurts. Oh, hurts so bad. It hurts so bad. Oh my god. Almost. All right, let's leave this for tomorrow. Wow. But this is definitely the solution. I think it's just a little bit tweak, maybe. Yeah, maybe a little bit tweak, and then we can get this. We can get this. And when we get this will be very fast. All right, that will be it. It's been an hour. Good. We start from 20. Tomorrow will be the fourth day. Okay, tomorrow will be the fourth day working on this. One of them, I mean, I really like this problem. I really like this problem. Anyway, I will see you guys tomorrow. Adios.